Let's look at graphing a parabola. For example, let's sketch the graph of this quadratic function f of x is equal to negative 3x squared plus 18x minus 22, and then we'll find the maximum or minimum value of f, as well as its domain and range, and the intervals where it's increasing or decreasing. Now, to sketch the graph of a quadratic function or a parabola, we plot the vertex and a few points on either side of it. Our quadratic function here is written in standard form, and what we need to do is convert it to vertex form. That is, f of x is equal to a times x minus h squared plus k, where hk here is the vertex. And the way we do that is by completing the square. So we have f of x is equal to negative 3x squared plus 18x minus 22. And now the first step in completing the square is to make sure that the coefficient of the square term is 1. And right now it's negative 3. So what we'll do first is factor in negative 3 out of these first two terms. That is, this is equal to negative 3 times x squared minus 6x. And let's leave a little bit of room here, and then we still have the minus 22. And now the next step in completing the square is we take 1/2 of the coefficient of x, which in this case is negative 6, which gives us negative 3, and then we square this. So we have negative 3 squared, which is equal to 9. And then we add and subtract that within the parentheses here. That is, we have plus 9 minus 9. And now these first three terms will form a perfect square, but we'll need to get this negative 9 out of the parentheses. But remember, we have to multiply by this negative 3. That is, f of x is equal to negative 3 times x minus 3 quantity squared, and then negative 3 times negative 9 is positive 27, and then we still have minus 22. Or f of x is equal to negative 3 times x minus 3 squared plus 5. And now comparing this to our vertex form over here on the left, we see that a is equal to negative 3, h is equal to 3, and k is equal to 5. And since a is less than 0, our parabola will be opening downward, and our vertex is at 3, 5. So let's plot the vertex. Let's say that this is the y-axis, and this is the x-axis. So we have 1, 2, 3, and then 1, 2, 3, 4, 5. So the vertex is here at 3, 5. And when finding other points, we're going to use the fact that the parabola will be symmetric about this axis of symmetry, namely x is equal to 3. Namely, if we choose x values to the left of 3, like 1 and 2, for example, that's going to give us corresponding values to the right of 3. So let's compute what y is equal to when x is equal to 1, which we can do by plugging in x equal to 1 down here in our vertex form of our function. So when we do that, we plug 1 in here. We have 1 minus 3, which is negative 2. Negative 2 squared is 4. 4 times negative 3 is negative 12, and negative 12 plus 5 is negative 7. And when we plug in x is equal to 2, we have 2 minus 3, which is negative 1. Negative 1 squared is 1. 1 times negative 3 is negative 3, plus 5 is 2. So let's plot 1, negative 7, So this is -1, -2, -3, -4, -5, -6, -7. So 1, -7 will be here. And 2, 2 will be up here. And now because of symmetry, we know that 4, 2 also has to lie on our graph, as well as 5, -7. So our parabola will look like this. So it's very helpful to use this axis of symmetry to get the other points. That is, by knowing this point 2, 2 lies on our graph, we can conclude that 4, 2 does as well. And that we knew this point 1, -7 lied on our graph, then we can conclude that 5, -7 does as well. And we'll just darken in the vertex here too. So here's the graph of our quadratic function or our parabola, but we're still asked to find the maximum or minimum values of f, its domain and range, and intervals of increase or decrease. Now, because this parabola is opening downward, it will have a maximum, not a minimum, and the maximum will occur here at the vertex. That is, the maximum value of our function is the y-coordinate of that vertex, or 5. It occurs at x equal to 3, but the actual maximum value of the function is the y-coordinate, or 5. And the domain is all real numbers. And the range is from that vertex down, or the interval from -infinity up to 5. And we see that to the left of that vertex, the graph is rising, and to the right, it's falling, which means that the function is increasing on the interval from -infinity up to 3, and it's decreasing from 3 to infinity. And remember that increasing and decreasing are defined on an interval, not pointwise, but in terms of intervals. So we could have included 3 on either of these intervals, and we would have been correct. All right, and this is how we work with the graph of a parabola. Thank you, and we'll see you next time.